about vertical angles in linear pair, their definition, and how we can use them to solve for missing angle measures. So, please take out a ruler, protractor, and a piece of paper. And please draw two lines crossing each other like this, a big X, and measure the four angles. And I would measure them with you using my handy protractor from clicking this button. So, please note that based on your picture, your angles will probably be different from mine, and that's okay. So this angle has an angle measure of 133 degrees. Bringing my protractor down this way. You see that this angle measure right here is also 133 degrees. Now, stopping right here for a second, what do you notice about these two angles? They are opposite, and they have the same measure. What about the other two angles? This angle has a measure of 46 degrees. And this angle has a measure of also 46 degrees. Very sneaky here. So we have two angles. Take these two angles for example. They're opposite each other and they're the same. Same goes for these two angles being opposite and they are the same. Well, you just made a nice discovery. These are vertical angles. And the proper definition is that vertical angles are angles that are opposite each other when two lines cross and they have the same measure. Oh, now it all makes sense. So, based on this picture, which two angles are equal to each other? If you said A is equal to B, you are correct. If you also said B is equal to D, you are also correct. Because they are angles that are opposite each other. Therefore, their measure will be the same. And if you still don't believe me, let's check out this one. Here is repeat the definition again. I have two opposite angles, right? Like 56 and 56, they're the same. And we have two opposite angles that are measured 124. Let's see what happens if I move this way. Angle D would be the angle right here is less. However, if you look at these two opposite angles, they're still the same. Look at these two opposite angles, they're still the same. Same time we move C, see this way. Opposite angles are still the same. And you can't see right here, this also says 134. So, to recap, we've learned that vertical angles are two angles that are opposite each other when two lines cross, like a big X, and have measures be the same. Now let's move on to linear pair. Linear pair are two angles that are adjacent to each other, which also means next to. They share a side. And linear pair is supplementary. Now from the previous class, we learned that supplementary angles add up to 180 degrees, and complementary angles add up to 90. Therefore, we can just say linear pairs add up to 180 degrees because of the fact that they are supplementary. Therefore, based on this picture, x and y share a side, they are next to each other, they are a linear pair. If you don't believe me, check out this link. Here we have an angle measure of 56 degrees. We have an angle measure of 124 degrees. Add the two angles up, they equal to 180. Now, let's see, like this computer says, drive the orange dot. If I move it this way, the angle change. However, their sum will still be 180 degrees. If I move it down just slightly, close, give it a small angle measure of 1. Add it to the big angle measure of 179, and what does that give you? 180 degrees. So, here's some examples where we have to determine if the labeled angles are vertical, linear, or neither, based on our previous definitions. Let's recap. Vertical angles are two angles that are opposite each other when two lines are crossed, and they have the same measure. A linear pair are two angles that share a side, they're next to each other, and they are supplementary, which means they add up to 180. So, problem A. Label angle 1 and 2. What can you notice about that? You said that they're next to each other. You are correct. So therefore, what kind of angles are they? She said linear pair. You are correct. Therefore, A is a linear pair. Now let's go for B. Angle 3 and 4. This is really tricky. Well, you can tell from A, they're not next to each other, so they can't be a linear pair. But are they vertical? Are they opposite each other? What do you think? Not quite, huh? Because if you notice, here's your one linear lines. You kind of have two separate lines going in different directions. So they're not really crossing that line right here. They're like branching off. So technically, angles 3 and 4 are not vertical. Therefore, and they're not linear, as we can see, because we already proved that these angles 1 and 2 were linear. Therefore, B, the angles are neither. So, by ruling out already linear pair and neither, and noticing that you have two lines that are crossing each other, you have two angles that are opposite each other, what do you think the name of those angles are? Vertical. So, to recap again, linear pair are two angles that share a side, they are next to each other, they are supplementary, which means their angle measure adds up to 180. And vertical angles are two angles that are opposite each other when two lines are crossing, and their angle measures are going to be the same. So now let's try using with numbers. Here we are asked to find the measure of angle RSU. R, S, and U. And I drew a little angle sign. And we are already given that TSU is 62 degrees. What do you notice about these two angles? If you said that they share a side, you are correct. If you said they were next to each other, you are also correct. So therefore, what kind of angles are they? A linear pair. And we know that a linear pair angle measures add up to 180, which is because they are supplementary. So here we can simply say the measure of angle RSU plus the measure of angle TSU is equal to 180 degrees. Now, since we don't know the measure of angle RSU, However, we do know the measure of TSU. We can simply substitute the angle measure that we are given into this equation. Therefore, our next line would be measure of angle RSU plus 62 is equal 180 degrees. To get measure of RSU by itself, we subtract 62 from both sides. Our next line will now be M RSU, which is measure of angle RSU, equals, because this cancels, 118 degrees. So that's how we use the definition of linear pair to create an equation and find a missing angle measure. Now we are given two lines across, and we are looking for the measure of angle CED, which is this angle right here. Now, like I said, two lines crossed. This angle is opposite this angle. So to show a picture, what can you conclude that the measure of angle CED is going to be? 50 degrees. Because they're angles that are opposite each other. You have two lines that are crossing. So therefore, the angle measure are going to be the same. So we can just say CED is equal to 50 degrees. And here we actually use the definition of vertical angles to solve for a missing angle measure. Okay. Here's a little recap about algebra. Using variables. Here we're going to find the value of y. So here's our picture. We are given two angles, 4y minus 42 and 2y. What do you notice about these two angles? They are opposite each other. So therefore, they must be what? Vertical angles. And what do we know about the measure of vertical angles? They are the same. So now you can develop an equation like so. Because, back to the definition, this angle measure is going to be the same as this angle measure because they are vertical angles. And by the definition of vertical angles, the measures are going to be congruent. So, let's combine like terms. Let's subtract 4y from both sides. Next line will be 0 minus 42. So I'll just write minus 42. And 2 minus 4 will be negative 2y. Because also on the number line, to see it, you start at 2, and you're going down 4. Which means you're going to pass 0 and go 2 places from 0, which is negative 2. So, to isolate y by itself, simply divide both sides by negative 2. Therefore, our final value will be y equals 21 degrees. Positive 21, because you have a negative divided by a negative, which will give you a positive number. And so, let's do some more practice. I have 3 problems here. Let's find the value of the variable. Now, starting with number 4, I have 2 lines that are crossing. Even though it's not like an X, it's still crossing to make a T. What do you notice about these 2 angles? They are opposite, so therefore, they are congruent. So based on the last problem, I'll refer back. We set up the equation as so, setting the 2 angles equal to each other, which we can do right here again. And like before, to get r by itself, we'll first subtract 3 from both sides. we're left with 2r equals 86. And like before, to get r completely by itself, divide both sides by 2. Therefore, r equals 43 degrees. Now, since we had 2 examples of our vertical angles, as you can see, number 5 gives you vertical angles again. So, I'm going to let you do that at home on your own and comment to see what answer you get. And let's move on to actually number 6. Problem 6. We have 2 angles that are next to each other. What do we know about 2 angles that are next to each other? They are called linear pair. And what do we know about linear pairs? They are supplementary, which means their angle measures add up to 180 degrees. So, like the slides before, we were able to set an equation like so, and then solve for the missing angle measures using algebra. And that's exactly what we can do right here. I press extend page to give us more room. So, 20t plus 15t, we'll put plus 5 here, that goes with the 20t, equals 180 degrees. Combine like terms, that's why I put the like terms next to each other to make it a little bit easier. You have 5 plus 35t equals 180 degrees. Now, first step to get t by itself, simply subtract both sides by 5. Our next line will be 0 plus 35, so I just simply write 35t equals 175 degrees. And the last step to get t fully by itself is to divide both sides by 35. Therefore, t will equal 5 degrees. So, to recap, today we learned about the definitions of vertical angles and linear pairs and use those definitions to find missing angle measures either as an algebraic standpoint and just by a contextual standpoint. Tomorrow, we'll be coming back to this topic and do more problem solving using the definitions and applications we learned today. However, that's tomorrow. So, if you want to comment and tell me your answer for number 5, you have mastered vertical angles. And if you want to test again at linear pair, comment again, and I will send you a problem with a linear pair. So, have a good night.